Hello, welcome to my page where we we try as much as possible to simplify the practice of quantity surveying. Thank you for staying tuned. And if this is your first time of coming across my videos, I can assure you that there are other videos on my page that that you will find helpful and useful in the course of your practice of quantity surveying. If you will permit me to refer you to my YouTube page, which you can find at www.youtube.com/quantity surveying made easy underscore 2014. There you can find videos ranging from taking off, rate build up, pricing of preliminary items, how to control materials on site, how to measure electrical works, uh, and uh, and other useful materials. And please don't forget to like my page and also subscribe to my channel to encourage us to do more. We are going to be taking off for plumbing works. And as you can see on my page, I have a network of pipes running across around the building, which is the supply pipe. Basically, this is not my area of focus today, but I just needed to uh, take an overview of the plumbing entirely. Then we'll now go to where my interest is. Basically, as you can see, just like our rule book, the BESNM says that if you are measuring plumbing, you are measuring a pipe works, you're going to take the whole length, including where the joints are occupying. So you can see that if you want to measure the pipe reticulation around this building, it is straightforward. Then you now pick the joints, uh, appropriately. As you can see, we have a lot of T's. You have a T joint here, you have an elbow, you have a T here. And the T here is going to be a reducer T because the T is going to be a 32 by 32 by 19 because the pipe proceeding further is a 19 diameter pipe. Then here you have a T, you have an elbow here, you have a 25 pipe here. So meaning that the joint that is going to be here is going to be a 32, 32, 25. So you take it appropriately. You have a 32, 32, 25. You count how many 32, 32, 25 of the three ways joints you have here. You have an elbow here. You have an elbow here. You have possibly a rising pipe if the building is an high-rise building that takes water to the upper floor, then veer off into the respective floors you have in the buildings. First, the water comes from the main to your tank. Then you have all the booster, the booster, the gate valves, and everything in this area location. Here they are going to give you have precisely, they have already said it. You have a 1 horsepower water pump. You have 1 standby. You have which is this. You have a surface water tank. You have elevated water tank, and also the surface is the reservoir, while the elevated, where the booster pumps up, then this takes the water into the building and all of that. So the next will go to the soil water. The soil water, as you can see, this is also how the pipe network runs to to the safety tank and the sockaway. Basically, you have the chambers. The pipes are connected to the chambers. Mind you, these chambers are a composite. In terms of building up their rates, they are composite unit, and they are categorized within some certain range. Say if the depth between the first the depth between the first chamber to the last chamber is say 2 meter depth difference. So and meaning that you're going to build up rate for say maybe your first category will be say 600 depth to 1 meter, then 1 meter depth to 2 meter or 1.5, then 2 meter to 2.5 depth uh, chambers. Then you pick them, you now get the numbers that falls within the categories of 600 to 1 meter. That will fall within the range, within the rate you have built for that category. Then the one for 1 meter to 1.5, the same thing. So, and probably the pipe, basically you are taking the pipe measurement from one chamber to the other. Then possibly you have riser pipes, which you are going to see during the course of measuring the waste from the main building. Then that will now tells you where you have the down pipe, the pipes that takes the soil from the upper floors to the chambers, to the chambers, like as you can see. I think these chambers are indicating the ones coming from the top and all of that. So this is my area of focus. This is my area of focus. For you to understand how to measure the cool and hot water supply, first, you must have the knowledge on how these pipes are being laid on site. Secondly, you can internalize the isometric view of how the network is on the wall. Then it will now enable you know where you have different kind of joints that you need to pick. Some other persons can approach it by, first of all, drawing an isometric sketch of this. Because if you draw the isometric sketch of this, it will tell you where the pipe is starting from. If the pipe is coming from the ground floor, running all through this, then you have a rising pipe that rises up, say for this shower, where you have the mixer pipe is usually placed at 1.2, usually 1.2. So your pipe that is rising will rise from the floor to 1.2. Then you have an elbow. Then, as you can see, this is a pipe rising up to the next floor. And what is the size is a 19. So you're coming from 32, 25, 19. You have a gate valve. Then you have angle valves at different locations at the point of entry to each of the fittings, which you count separately. But if it is a composite rate where you needed to build up the rate for everything that will make this work, which means see the water tank, the WC, the pan collector, the flexible connector, then you have the angle valve, then you have what do you call it, the nipple, the male and female bushy, because the pipe coming out from the wall is either bigger than the flexible connector threaded knot. Then you have to now provide a nipple that will either reduce the pipe, that will reduce the size of the pipe to fit into your flexible connector. So if you draw the isometric drawing, it is more clearer. But if you can internalize it, you can take off for this without having to draw the isometric. So that is what we are going to do. Without the isometric, we are going to take up, we're going to extract all the joints that we have, the joint that we have in this toilet. So let us start with the cold water. The cold water is entering from here because this other one is the riser pipe that is taking the water. This gate valve is for the riser pipe going up. But this one is the one that is supplying the whole of this toilet. Mind us that the hot water only comes from the water heater. You have a cold water supply to the water heater after the water is hot. Then you have a pipe that will drop it down to the mixer where it can now be mixed for your to the appropriate temperature that you need for your beating. So you now have this joint entering here. So meaning that I have a 25 diameter pipe coming to the gate valve. Then I am having a gate valve of 25 mm. Then I'm now having a reducer after the gate valve that will now reduce this pipe to a 13 because the pipes inside of this toilet, they are 13 mm dia. So you have a reducer, either a nipple or a bushy that is going to reduce the pipe from 25 to 13. Then after which you now have a T here that now takes water to the water heat to the wash hand basin, then supplies to the water heater, also supply to the shower point. So we'll start from this direction to the shower point. So what we need to know now, if we're going to take cold before we take hot. Now the pipe is coming from the floor level all through, gets to this point, goes up to 50 mm high, then comes out of the wall. So meaning I have one elbow here and I have another elbow at 50 mm dia. I have one elbow at 50 mm high, so meaning two elbow. Then I have another elbow making 3. Then as I am going towards this direction, here is a T, but what we are taking now is elbow. So, and the pipe gets to this plate. Now, at this T, the pipe is going to rise up to 50, then another elbow. So now I have 4 elbow. So I have taken the elbow here. So I have 4 elbow. So you now follow this pipe directions again. You are now follow this direction again. Then when I get to this place, I have a T. So the pipe now is going to rise up to a 1.8, where you have the location of the water heater, then comes out of the wall. So you have 1 elbow there at 1.8 because it is a T that is taking the pipe from the supply. Then as I am going again to this joint, I have another elbow. So now the elbows are now 1, 2, 3, 4, 5, 6, 6 elbow. Then I get to this place, I have 7 elbow. Then as I am going up, I'm coming up to a 1.8 to a 1.2 where I have where my mixer tap is going to be located, either a concealed mixer tap or a surface mixer type. I have another elbow, meaning I have 8 elbow. So I now go to my already prepared sheet. I now go say bedroom toilet, ground floor. I put 8 elbow here, but for let me take time to explain this spreadsheet before we go back to our measurement. Like I often say, if you prepare a sheet of this in this manner, it enables you modify whenever you are measuring a different uh, drawing entirely. What you need to do is for you to change the features in the legend. If say that building is either smaller or is bigger, is to increase the rule and add additional fittings, sanitaries that you have in that building that you were not having in the last taking off that you undertook. As you can see, I have different types of different type of sanitaries. You have the large water closet, you have the medium water closet, you have the wash hand basin, water heater, 25 liters, 30 liters, the bathtub, the angular jacuzzi, the small, big jacuzzi, small, steamer, L-shape shower cubicle, kitchen sink, mixer tab, shower mixer, kitchen mixer tab, extractor, kitchen extractor, pan collector, flexible connector, floor drains, mirror, toilet holder, soap dish, towel hangers, so on and so forth. Then the next format is for soil water pipe, where you have the 400 diameter pipes, 300, 150, 150. You have the joints, the elbow, the 90 elbow, the 45, the T, the reducer, the socket, the plugs. Then you now have the hot and cold water. It could be a PPR pipe, it could be galvanized pipe, whichever pipe that is recommended. You can just change whatever and all of that. So having taken us through this sheet, let us go back to our measurement. We've been able to get X elbow. So we now go again. So let us now go for the T. So now you have 1T, you have 2T, you have 3T, you have 3T in this toilet. So I go back 13 mm diameter T. I go to, sorry, I was putting this at the wrong place. I have 8. It's not the pipe. So I go to my T. I have 3. Then we go back to the sketch. I have my T, cold water, 3T. So let us take the hot water. The hot water, the pipe is dropping from the water heater. Then you have a T here that takes the water to the water to the wash hand basin. Then you have the one that takes the water to the mixer tap. So now I'll count one elbow at 400 at 500 high, one elbow at the bottom, 2 elbow making 3 elbow. Then at the point of 1.8, at the point of 1.8, I have 4 elbow, then 5 elbow, I have 6 elbow, I have 7 elbow. So I have 7 elbow in addition. I have 7 elbow in addition to this. I have in addition to this, so I'll just add 7, making 15. So making 15. Then we go back to our sketch. So we're having 1T. So I'm adding 1T to the T we have here, plus 1, making 4. So I will go to the reducer nipple. Reducer nipple at the point of exit. I'm going to have two flexible connector here that will take the cold water into the basin. So I have 2 reducer I'll reduce the pipe from 13 to the size of the flexible connector, the screw head that is in the flexible connector. So I'm now going to take 1, 2, 3, 4, 5, 4, 5. So I have 5 reducer, which is I'll now come to so I'm now going to take 5. Then I have the same, then I have 5. Then how many gate valves? Let's go to we go to the drawings. So if I am to count the number of flexible connector, I'm going to count, I have 5 flexible connector and 5 angle valve. So I'll go to my sheet. I'll look for where I have the 5, I go to I say ground floor, I say bedroom toilet. So I have 1 water closet. I have 1 wash hand basin. I have 1 water. I have 1 whatever, if it is a 25-liter water hot water heater. Then we go to the jacuzzi. There's no jacuzzi. Then I have the location. I have a cubicle. So this cubicle is an L shape because I'm going to put the glass is going to run through this direction to this direction. So I'm going to take an L-shaped cubicle. So an L shape, I'm having 1. Then I have a basin mixer tap, 1. Then our shower mixer tap, 1. Then pan collector, 1. Flexible connector, 5. Floor drain, 1. Mirror, 1. Toilet soap holder, 1. At the toilet roll holder, 1. Soap dish, 1. Towel hanger, 1. If there is suit hanger, you put 1. Hand dryer, you put 1. Liquid soap, 1. Fan extractor, we go to the drawing. If it is there, you take 1. So as you can see, I've been able to measure the whole of this toilet, remaining the pipe. So now what I don't need to do now is to go to the cold water pipe, which is a 13 dia pipe. I go to my sketch. I go to the well-dimensioned drawing, and I know what the distance from this location is to this location. I take the length of the pipe. I take another distance of this location. I take the pipe. I take to this distance. I take the pipe. Then I take the pipe going up. I take 501 here, 502 here. Then here I'm going to take a 1.8. I'm going to take a 1.8. I'm going to take a 1.82 because this pipe is coming from the bottom, from the floor to a 1.8. The pipe again is coming from the 1.8 down that will supply to this point. I take a 1.82 of 1.8. So I have 2 of 1.8. I have 2 of 500. Or let's take it one after the other so that it will not confuse. So we start from the same direction we went. So I have this pipe that is coming up from the ground, 500, 502. I go to my bedroom. I put 0.5 times 2. Then I go back again, which means I have taken these two pipes going up. So let's assume from this location to this location, since this drawing is a PDF drawing, we can't scale. Let's assume from here to this direction is a 1 meter. And from here to this direction is is 0.8. So I go back to my sketch. I take I now say plus 1 plus 0.8. I have taken this, I've taken this two, the hot and cold. So now I am taking this one all stretch, and I'm taking this one all stretch as well. So if this toilet say it is a 2.5, I'm going to take this two pipe 2.5 by 2. This is an assumption because we don't have sketch for it. We don't have a right the length. So I now say 2.5 times 2. So I now go back again. So I've taken these two pipes. So I'm left with this 500. So since I have another 500 here, I'm going to add it to this one to become 3. So I'm going back to this, and I'll just change this 0.5 to 3. Then I go back to my sketch. Then now I am at the water heater. This water heater, the supply, the cold water supply is a 1.8 to the location where you have the water heater. Then the pipe supplying the hot water is coming from 1.8 down as well to 1.8. So you have two 1.8. So I go back to my location where I have my pipe. I take 1.8 times 2. Then I go back to my sketch again. I am through with the pipes that supplies this water heater. Then I now come to this direction now. I have this pipe. Let's say this toilet is a 1.8 width. So let's say we are taking a 1.2 from this direction to this, from this point to this point. So I have a 1.2 times 2. Then I now have another pipe that is rising up to the mixer type at 1.2. So I have 1.2. For us not to be confused, let us take this toilet to be take this location to be 3 meters, and we take this to be 2 meters. So this 2.5, I am converting it to 3 meters. Then the other location now, we say we're going to take a 1.8, times 2 plus a 1.2 times 2, meaning this hot water running at the floor level is 1.8. This one supplying the cold water to is 1.8, but the one taking the pipe upwards to now connect the mixer tap is going to be at 1.2 because your mixer tap location is 1.2. So I'm taking the one going up 1.2 and its 2 number. I'm taking this one that comes from this location because we assume this the width of this toilet is 2 meters. So we assume it is 200 apart from to the end. So that's why we're taking 1.8 times 2, and 1.2 times 2. So as you can see, I am done with this. The only thing we have not measured, we have not counted, is the angle valves. We have 5 angle valves because the angle valves are the gateway where the water comes from the wall before you connect the flexible connector. So what I'll just do, I just go back to this place, this location, either add, then I call it angle valve. So I have 5 numbers. So you can see I've been able to take this take off for this toilet. So as soon as I'm done with this toilet, I'll go to the next toilet, I'll go to the kitchen, then I'll go to the next floor. When I take them in that direction, before I will now come and I'll account for the pipes, the external pipes, account for the external pipes. Then this riser pipe that takes water to the floors, you look at the locations where they are. Look at you can see they have one riser here. They have one riser here taking it up, and you have another riser here. Then we look where the risers are. When we get to the next floor, we look where the risers are, where the toilets are located, and how the pipes are connected to those toilets. Then we know if it is a riser that is feeding the toilet up. We take the length of the pipe from whatever location, whatever height it is going to the ground floor, and put it appropriately where the size is. After doing that, you can see I have my toilet intact. So please, if this illustration have been able to help you to understand the basis, which it's not my approach is not the end, but it's just another approach to the measurement of plumbing works. Please, you can like my page, give me a thumbs up, and at the same time, if there are gray areas where you want me to throw more light, you can drop me you can drop a message on my page. I will certainly answer you. But above all, subscribe to my channel, like and share to friends and colleagues in the industry for for them to share from the little expose that I have been able to share on this video. Thank you. See you next